Welcome to this video. We're going to be talking about geometric sequences. This is aligned with mathematics analysis and approaches, standard 1.3. So when a sequence grows by constant multiplying or dividing between the terms, this is known as a geometric sequence. So for example, 8 to 4 would actually be divided by 2 or times 1/2. 4 to 2, again, same thing, times 1/2 or divided by 2. And then from 2 to 1 times 1/2 again, or divided by 2. And the process continues. Or it could grow. So from 3 to 9 would be times 3, and then times 3 again, continuing on as the series grows. So that common ratio between each term we denote with the letter R. And each term of the sequence is written U1, U2, so on and so on, UN, where there are in terms. So we can derive the formula for the general term in the following way. The first term is U1. The next term is going to be U1 times R, the common ratio. The third term is going to be the second term times R. Well, that is actually just the first term times R squared, because R times R is R squared. Again, the fourth term would be U1 times R cubed. So on and so on, this process continues where this number is always one less than this one. So your general formula or general term becomes UN equals the first term times R to the power of n minus 1. And of course, n is a positive integer. Let's practice finding the common ratio and writing the next two terms of each of the sequences below. So 2.5 to 5 is times 2, and 5 to 10 is again times 2. 10 times 2 is going to be 20, and 20 times 2 will be 40. The next one is going to be times 1/3, times 1/3, and then 1 times 1/3 is 1/3. 1/3 times 1/3 is 1/9. This last one, to get from x to 2x cubed, we have to multiply by 2x squared, and then we do that again, times 2x squared. And so with times 2x squared again will give us 8x to the 7th, and then 16x to the 9th. So let's find the number of terms in the following geometric sequences. So remember, our general formula is going to be UN equals the first term times the ratio to the power of n minus 1. So in this first sequence, we have that the first term is 0.15 and the last term is 12.15. So let's find the ratio. So from here to here, it's multiplying by 3. So I know my R is going to be 3. Let's set up the formula with my value for UN. 12.15 is going to equal my first term, which is 0.15, times my ratio 3 to the power of n minus 1. So I need to solve this equation for n, and I'm actually going to have to use a logarithm. So let's do it. First, I'm going to divide both sides by 0.15, and that will give me 12.15 divided by 0.15. That equals 3 to the power of n minus 1. Now here's where you got to use a logarithm. You have to match the base of your exponent with the base of your logarithm. So you take log base 3 of both sides of this equation. So log base 3 of 12.15 divided by 0.15, and then log base 3 of 3 exponential cancels, and so you just get n minus 1. And then you just need to add 1. So log base 3 of 12.15 divided by 0.15 plus 1 equals n. You can put this into your calculator and you'll get the result is 5. So there are 5 terms here. Let's try one more. My first term here is going to be 440. My last term is going to be a huge decimal, 0.4296875. Let's find the ratio. So from 440 to 410 is times 1/4. So my ratio is 1/4. And I can write my equation with my value for UN. So let's write this decimal again. 0.4296875 equals my initial term, 440 times 1/4 to the power of n minus 1. And I'm going to do the same process as I did in the first example. I'm going to divide by 440. And then I'm going to take the logarithm. So my logarithm base has the mass as exponential base, 1/4. So my logarithm base is also going to be 1/4. And again, I got to write this decimal. 4296875. All that over 440. And then plus 1 is going to equal n. Plug this into your calculator and you'll see that the answer is 6. So there are 6 terms here. The first term of a geometric sequence is 4 and the common ratio is -2. Determine which term has a value of -2048. Let's write out what we know. The first term is 4, common ratio is -2, and the term we're looking for, un, is equal to -2048. So I can set up an equation based on the general term formula. -2048 is going to equal first term times -2 to the power of n minus 1. Divide by 4 on both sides gives me -512 equals -2 to the n minus 1. I'm going to do the logarithm, but logarithm base -2 doesn't exist, so I'm going to do it as if it was positive, and I know it will be the same answer. So I'm going to do log base +2 of 512 equals n minus 2. Log base 2 of 512 is 6, then 6 plus 1 is 7. So I know that -2048 is the 7th term of the sequence. Okay, the 4th term of a geometric sequence is 54, and the 6th term is 486. Determine the possible values of the common ratio. So the 4th term here is 54, and the 6th term is 486. I need to find the value of the common ratio. So remember, the formula is un equals u1 r to the n minus 1. I'm going to set up 2 equations. I'll start with 486 equals u1, which I don't know, r I don't know, but I do know that this would be 6 minus 1, which is 5. And the second equation is going to be 54 equals u1r to the 4 minus 1, which is 3. If I divide these 2 equations by each other, 46 divided by 54 is actually 9. And then u1 divided by u1 is 1, so that really cancels. And then r to the 5th divided by r to the 3rd is r to the 2nd. Take the square root of both sides and I get plus or minus 3. So r could be positive or -3. Alright, last example. The first term of a geometric sequence is 16 and the common ratio is 1/2. Find the biggest term that is smaller than 1000. This is going to look similar to the previous 2 questions with a slight change in that we're going to use a less than sign instead of an equal sign. So the first term is 16 and the common ratio is 1/2. Let's set up the equation. un is going to equal 16 times 1/2 to the power of n minus 1. I want to figure out when this is less than 1 over 1000. So I'm going to solve it as if it had an equal sign. And I'm going to get a decimal for n, and I'm going to round to the nearest n, and that will be my answer. So first I'll divide by 16 on both sides. So that's the same thing as times 1 over 16. And I get 1/2 n minus 1 is less than 1 over 16,000. Then I'm going to take the log base 1/2 of both sides. N minus 1 equals, sorry, not equals, less than log base 1/2 of 1 over 16,000. And then I just add 1 to that. I actually get 14.96 if I put it in my calculator. The closest value for n to that would be 15. So I know that after the 15th term of the sequence, it's going to be smaller than 1 over 1000. Alright, and that is it for this lesson. Go ahead now and try some practice on your own.